All right, we're going to talk about probabilities today. Okay. First of all, we need to understand what probabilities are. Okay. A probability is the measure of the likelihood of a certain event occurring. Okay. Where you probably most of all hear about probability is in weather. Okay. Probability it's going to rain, probability it's going to snow, probability it's going to have severe storms, just many different places in weather you hear the word probability. What we're speaking of mathematically today is similar to that, but it's not necessarily what we're talking about. Okay? When they're talking about the probability of rain and they say there's a 20% chance of rain, most of the time what they're talking about is the area that is watching them, 20% of it's going to get rain. Okay? So that's really not what we're discussing in the sense of, for example, I've got a bag full of marbles. You reach in there and you're going to pick out a green or a red one. That's a probability, okay, more so of what we're talking about mathematically than what they're talking about in rain, okay? Now, the probability is still the same as what it means, okay? When they say there's a 20% chance of rain or a 20% probability of rain, what they're talking about doesn't necessarily have to come true. I mean, how many times have you heard before there's a 20% probability it's going to rain and we get a flood, okay? And then they say another day there's 70% probability it's going to rain and it doesn't do anything, okay? So in that sense, the probabilities are the same. In other words, a probability is just saying, hey, here's what we think is going to happen. Doesn't mean it's going to happen, okay? The only time that it is for sure going to happen is when the probability is 100% or 1. For example, if I put a bag full of quarters on Derek's desk and I tell him to reach in and pull out a quarter, what's the probability that's going to happen? Well, unless Derek doesn't have, the capabilities of reaching in a bag, it's 1. It's 100%. It's going to happen. If I told Derek to reach in that bag of quarters and pull out a nickel, what's the probability of that one happening? 0. It's not going to happen. Okay? So there are probabilities that are this happened or this is going to happen. Okay? If you drive 100 miles an hour into a road that dead ends into a wall and your brakes don't work, well, there's a good chance you're going to crash, okay? So it is just that, what it is. Now, the easiest probability that we always talk about is flipping a coin, okay? Because there's only 2 outcomes to flipping a coin, heads or tails, okay? And so when we talk about flipping a coin, we talk about outcomes. Okay? That is how probabilities are decided upon, are mathematically figured out, is outcomes. There is a favorable outcome and unfavorable. Most of the time when you're talking about probabilities, we'll talk here in a little bit about odds. Okay, probability and odds are not the same thing. Okay, the odds of something happening and the probability of something happening are totally mathematically figured differently. Okay, but for our purposes, we're talking more so about favorable outcomes. In other words, what we want to happen is the favorable outcome. Okay, if I've got $1 million check sitting on this desk, and somebody's going to flip a coin, and heads it goes to me, and tails it goes to Josh, well, the favorable outcome to me is heads. Okay, the favorable outcome to Josh is tails. Okay, so it's favorable in the sense of something happens that we want to happen, not necessarily good. Okay, I would say that sometimes there's some favorable outcomes that are not always good for people. Okay, that people think are favorable. People that make money off of death and destruction. That's not a favorable outcome for most people, but it is for a person that makes, there's people like, for example, that have made tons of money in places like Haiti and places like that are destroyed by catastrophical events. To them it's a favorable outcome. To the people it happened to, it's not. Okay? So favorable doesn't mean that it's a good outcome. Okay? Favorable just means what it is. It's an outcome. Okay, a great example is if you live in Dallas County, you have a better chance or better probability of getting in a car accident than you do if you live in Tarrant County or in Fort Worth. Okay, the reason being is, A, you've got more people in Dallas, more people driving cars in Dallas, so that raises the probability that there's going to be a wreck. Okay, well, that's not a favorable outcome for Derek to have a wreck. Okay, but it is an outcome that they're looking at, for example, insurance companies look at to raise your insurance rates. I mean, if it's more of a probability that Derek, when he's driving, is going to get in a wreck in Dallas County, and he lives in Dallas County, okay, well, then he's going to have to pay more insurance because he has to insure that risk of the probability going up that you're going to get in a car wreck. If you live in a town of 5 people, okay, and that's the only place you really ever go is there, then your insurance rates are going to be very, very, very low because obviously there's not a whole lot of people running around the town for you to get in a car accident with. Okay, if it's a small town, something like that, and that is true for most. Okay, when we lived in Decatur, which is just 40 miles, 30 miles up the road here, it's not a very big town back when I lived in it. And so when I lived there, my insurance rates were a lot lower. When I moved to Fort Worth, they went up about 20%. Just simply because probability of me getting in an accident and them having to pay for it is going up. Okay? Now, so what I was trying to get you to see there is not every time is it a favorable outcome a good thing. Okay? A favorable outcome, a probability that it's going to have severe storms is not a favorable outcome to most of us. Okay, but it is an outcome that they're trying to figure their probability on. Okay, now, the actual formula for probability is favorable outcomes over total outcomes. Okay, we go back to the flipping of the coin. Okay, this is the probability formula. Probability is equal to the favorable outcomes over the total outcomes. Okay, well, if like I said a while ago when we were talking about that $1 million check, and I want a heads and Josh wants a tails. Okay, well, the favorable outcome to me is one thing, heads. Okay, so when you flip a coin, there are 2 total outcomes. Okay, it's either heads or tails. That's the total number of outcomes that you can have. Now, some might say, well, it could land on its side. No, it's not an outcome. Okay, it could get caught in a crack. Yeah, it could, but that's not an outcome. You don't get anything for that. Okay, but you have a heads and you have a tails. So the total number of outcomes is 2. Okay, the favorable one for me is the probability that I want it to land on heads. And that's how they write it. Probability, P, parentheses, and what the outcome is, heads. Okay? And to figure that, then, we just simply plug in the information. We know favorable outcome, there's only one head on a coin, unless you got a two-headed coin, obviously. If you have a two-headed coin, you want it to land on heads, then the probability of that happening is obviously 100%. Okay? So the probability I want a head, so that's one favorable outcome over the total outcomes of two. So that's 1/2, which is, some will say 50%, and some will say 0.5. Okay? If you look at the bottom of page 634, they have a little line chart there that basically shows you what you would probably already know. The probability that something occurs when it's 0 is impossible. Okay? The probability of other things you can see there, they got 0.25 unlikely, 0.5 it's likely that it'll occur half the time, then 0.75 is likely, and then obviously 1.0 is it's going to happen. Okay? Now, we have in the past, I have taken a coin and said that, hey, it's going to flip half the time on heads, half the time on tails. Okay? But that is not necessarily true. Okay? A probability does not mean, okay, in other words, if I have the probability I'm going to flip a head and it's 50%, well, that would mean if I flipped it 10 times, how many heads should I land on? Huh? If I flipped it 10 times? 5 times. Okay? If I flip a coin 10 times, 5 of those times, by probabilities, 5 of those times it should land on heads, 5 of those times it should land on tails. Okay? Well, obviously there's a bunch of different things that could go into that. Okay? Are we flipping the coin and letting it land on the ground? Are we flipping the coin and putting it in our hand and then flipping it again? How people flip it and catch it and do that? Well, it seems like if you flip it and caught it, that should be the one that, that it should be. It shouldn't be the one you flipped here, because now you've flipped it basically twice. But that's why when you see like NFL games, they flip it and let it land. They don't catch it and then turn it over. They flip it, let it land, and everybody's doing this. Hey, is it a favorable outcome or is it not? The other thing is quite honestly, I have found through the years that we have done that what the coin starts on, in other words, if I always put it on heads when I flip it, it tends to be leaning toward landing on tails. That's why when I'm at a game, like we're in a baseball tournament and they're flipping for home team, I'll try to see if I can see what the guy's got it on, and I'll call the opposite. In one tournament, I literally went through that. We played like 4 or 5 games, and I got every single call right by doing that. And we have found in the past when I've done a little experiment that, you can sometimes tell. But what we also found is this. I've done it probably 10 different times throughout the years I've taught this probability section. Probably done it 10 times, and of those 10 times, not a single one of them came up 50-50. Never did. So what that tells you is a probability is just that. A probability doesn't mean that it's going to occur just like they've said it is. A probability is simply how many times that we think it might occur or it should occur by all the information that we've gathered. For example, there's probably 90-year-old people in Dallas that have been driving since they were probably 12 years old, if they're 90, and never got in a car accident. Well, the probabilities would say that you're probably going to have, there's a 30% probability that you're going to have a wreck in the time that you drive. Okay? Well, but people prove that probability wrong every time, just like the probability that somebody's going to get struck by lightning twice is very, 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 very large. Okay? But there have been people struck by lightning twice. Okay? The probability that you're going to win, the Texas lottery starts out at like 1 in 715 million. But do people win the lottery? Sure they do. Okay? So probability is just simply that. It's a mathematical way for us to try to put some information together and figure out what's going to happen. Okay? Like, for example, the probability that it's going to snow today is 0. Okay? Because of the information we know. A, it's not below freezing, not even close to freezing. It's sunny. Now, could it happen? Sure it could. Okay? It could happen. It would probably be a major miracle, but it could happen. So you can't say probably that the probability is simply 0. Now, obviously, some things would have to change. It's not going to snow when it's 60 degrees. Okay, unless it is a miracle. Okay? Just like it's not going to rain for 40 days and 40 nights unless, something happens. And well, yeah, but it's still, like I said, it's not going to snow when it's 60. Something would have to change for that probability to change. Okay? Just like, the probability that it's going to be hot this summer. Well, the probability it's going to be hot in Fort Worth, Texas is 100%. It's going to be hot this summer. Okay? We are going to have days over 100. So understand that a probability is simply a educated guess on the chances that something is going to happen. Okay? So understand that it is that. Now, let's look at a couple examples. First of all, let's talk about this before we move on. Let's talk about the difference between theoretical probability, okay, and experimental probability. Okay? Now understand that the lower the number gets, the less likely that something occurred. For example, if I have a probability of 1 over 1 billion, okay, there's a very slim opportunity for that event to occur. Okay? So understand that the smaller the number gets, or the bigger the number gets on your fraction, on the bottom part of your fraction, the less likely the event is going to happen. Okay? Theoretical probability is simply, we've sort of already talked about it. Theoretical probability is the probability that something is going to happen. For example, flipping the coin, landing on heads. Okay, the theoretical probability of that is 1 over 2. Okay? Experimental probability is us flipping the coin 10 times and seeing if it lands on heads 50% of the time. Okay? So experimental probability is proving, let's do this. The experimental probability is the trials to prove a theoretical probability. Okay, and we'll put in parentheses, flipping coin 10 times. Okay, flipping a coin 10 times to prove that theoretical probability that, here's a theory, it's basically a theory. If I flip a coin, then it's going to land on heads half of the time. Okay, that's really the difference. The theoretical probability is the theory behind it. Okay, the experimental probability is the trials that we try to do to prove it. Okay, or to see if it truly is a correct theoretical probability. All right, now, most of the time when we're talking about probabilities in this book, they're going to use examples like spinners, they're going to use dice. You roll dice. What's the probability that I'm going to roll a 6 if, you got one dice? They're going to think about marbles. Okay. So turn to page 230 or 636 and look at the bottom, or look in the middle, basically. They have that set of marbles there. Okay. That set of marbles says you randomly choose a marble from the marbles below. Obviously, in all of this, okay, in a lot of these things like this one, we're going to pick a marble. Obviously, for a probability to hold true, you can't see them. Okay, if I just set some marbles on a desk and say pick a blue one, the probability of that happening is 100% because you can see them. Okay, unless you're colorblind. Okay, if you were colorblind, then yes, the probability would hold true. Okay, but if you got to assume that they can't be seen in probabilities like when you're picking something, because random doesn't happen if you can see what you're trying to pick. It wouldn't be random. They'd have to be in a bag that you can't tell, you can't see. They'd all have to be the same size. Okay, if we got one huge marble that's the size of this, and then all the rest of the marbles are the size of the penny, okay, then obviously somebody's probably going to pick the big one. Okay, so that's not a true probability. A true probability is, especially when you're picking things, is that there is a random chance of it happening. If and I know several of you here are, if you've been watching any of the, NCAA basketball tournament, Lord have mercy. They have inundated us with every kind of probability and statistic of this person finishing. I mean, every time somebody gets eliminated, it's like, oh, okay, well, the probability of, Dayton going to the Final Four has gone up, or the probability of Michigan State going to the Final Four has gone down, and they just hit us with these probabilities and statistics every single day. It's so frustrating that, they do the same thing in every sport. When the Super Bowl happens, the probability is going up and down. Well, it doesn't go up or down unless somebody's injured. It's either, bottom line is this team, they should stay this way. Okay? If the probability was here the first week, then the second week when they're fixing to play it, it should be exactly the same unless somebody got injured, or a coach didn't show up, or somebody had a death in the family, or some extraneous circumstance happened to the team. Okay? I mean, for example, Florida in the NCAA tournament, their probability of winning the tournament should have been exactly the same when it started until it ends. Okay, well now they're saying, well, their probability's gone up because now you don't have number 1 seeds in the Final Four, blah blah blah. Well, the bottom line is, if a team's better than a number 1 seed and they beat them, then maybe they should have been a number 1 seed. Okay, so you're just inundated if you watch any kind of sports program about winning and losing, anything like that. You're going to be inundated with probabilities and statistics. Okay, and so, but the bottom line is they don't have a clue. I mean, if we really did have a clue, then everybody's brackets would have had UConn, Florida, Wisconsin, and Kentucky. If all these probabilities panned out, that all these experts are supposedly giving us, then everybody in the United States would have the same bracket and blah, blah, blah. Okay? So that's what it is. Probability is marbles. It says you randomly choose a marble from the marbles below. Find the probability of choosing a marble of the given color. Write the probability as a fraction, a decimal, and a percent. Okay? So they want to know what is the probability that you're going to choose a blue marble. First of all, how many marbles are there? 20? Okay? So there are 20 marbles. Okay, so they want to know the probability that you're going to choose a blue one. Well, we already know that the bottom number then should be 20 because there's 20 total marbles. Now we need to know how many blue ones there are. 6 blue ones? All right, so there's 6 blue ones. So I put that number on top. Now, I need to reduce that. 3 over what? 3 over 10. So the probability that it's blue is equal to 3 over 10. You must reduce your fractions when you do the probability. Most of the time, they don't. So, well, I'd say some of the time, they give you where they want it like now, where they want a fraction, then they want a decimal, and then they want a percent. Okay? But the fraction part of it must always be simplified to lowest terms. Okay? Matt?
So when we reduce, you want it to lowest?
Yes. Always to lowest terms. Okay? Now, 3 over 10 as a decimal would simply be 10 into 3, okay? But you should know that is 0.3. Okay, so 0.3, 3/10, 0.3, which makes it as a percent what? 30%. Because remember, to change 0.3 to a percent, we simply move the decimal 2 places to the right. Okay, and so all 3 of these is the answer. So it's a 30% probability that you're going to pick a blue one. Okay, so what is the probability that you'll pick a yellow one? 0. Okay, because the yellow one's not in there. It's not possible. Okay, now look at number 15. Number 15 says, tongue rolling. You ask 80 students at your school whether they can roll their tongues. Of the students surveyed, 64 said yes. Find the probability that a randomly selected student can roll his or her tongue. Write the probability as a fraction, a decimal, and a percent. Okay? So, how many people are there that we surveyed? 80. So that's your bottom number. So the probability of tongue rolling is equal to 80 on the bottom for total students. And how many students said yes? Obviously, they didn't prove this out. They didn't watch, 64 students stick out their tongue and roll it. Okay? They just asked people. People could have lied, I guess, but obviously, we're assuming people didn't lie and all that. So, how many people rolled their tongue? 64. So that's your top number. Now, you must reduce. Okay, 8 over 10, 4 over 5. So you divide it by 8, and that got 8 over 10. Then we divide it by 2, and that gives you the 4/5. Now, so the answer to probability of tongue rolling is equal to 4 over 5, and 4 over 5 as a decimal is what? 0.8. And then 80%. Okay? So all of those would be your answer. Nicole?
Whenever you just do a decimal, you just look at
yeah, in that particular case, we came up with 8 over 10, and that's where we got 0.8. But what you're doing is you're simply taking 5 and dividing it into 4. You're taking the bottom number, divided in the top number. 5 doesn't go into 4. 5 goes into 48 times. And that's where we get that from. It's always bottom number into top number for division of fractions. Yes, Derek.
So like number 13 on that yellow, would you just do 0 over 20 and then 0.0 and then
Yeah, I mean that's fine. As long as you just put 0, I don't really care if you put all 3 on that because 0 is just 0. But yes, the reason it is 0 is because you have 0 over 20. 20 goes into 0 0 times, and then if you move the decimal and 0, it just keeps going. Okay. All right, now on 16, 17, and 18, I will allow you to use a calculator. Okay, because they're dealing with some fairly large numbers there, and so you can use a calculator on those 3 problems. So your homework. Your homework is 13.1, 1 through 21. Huh? No, if I said all the problems, there would be more than that. Yeah. Work less on that whatever work you're working on, and